And here are some examples of calculus 1. The first example is find the limit using graphic method. So this is as limit x approaches minus 4.5. So minus 4.5 is here. From the left, this negative means from the left. So that means if you walk in this curve from the left, you will end up at 3. So the y value is 3. Then limit as x approaches minus 4.5 from the right. You walk only when you walk on this curve from the right, you will end up minus 6. So that means the limit from the right is minus 6. So the limit from the right is not equal to the limit from the left. That means the limit does not exist. That means limit as x approaches minus 4.5, f of x does not exist. So the f of x of minus 4.5, you stand here and you look up, it is a whole, so down it is minus 6, so that is the value of f of minus 4 to the half is minus 6. So this means this function is discontinuous. You have a whole, and it's obviously you can see from the graph. Then I have an example of limit at infinity. So given f of x equals x squared plus 5x plus 6 over x squared and minus 4. So this is equal to, if you factor the top is x plus 2 times x plus 3. You factor the bottom, it's x plus 2 times x minus 2. X plus 2 cancels x plus 2. So this is x plus 3 over x minus 2. So to find the x-intercept, you simply set the numerator equal to 0, which is x plus 3 equal to 0. That is x equals minus 3. Then to find the y-intercept, you simply put x equal to 0. So 0, 0 here. So that is minus 3 over 2. Then to find the vertical asymptote, we simply set the denominator equal to 0, which is x minus 2 equal to 0. That is x equals 2. Then to find the whole, you set the eliminated part, which is x plus 2, x plus 2. You set that equal to 0. Then x equals minus 2 is the whole. Then to find the horizontal asymptote, you take limit as n goes to infinity of this one, or you can actually take of the x plus 3 over x minus 2, you will end up with 1. So this is basically you have all the information you need to graph this rational function. So then the next example I have is physics application in calculus. So you have distance formula is given, s of t of a bedrock is given 100 minus 10t plus 0.01 t cubed. So to find the distance at time t equals 2, then this is t equals to s of t, simply substitute 2, you will end up with 120.08 meter. Then to find the velocity at time t equals 2, then the velocity is the derivative of the distance is velocity. So you take the derivative of this, which is 10 plus 0.0013 squared. Then you substitute 2 into that equation. So that is, you will end up with, this is the equation, you will end up with 10.12 meter per second. Then the derivative of velocity is acceleration. If you take the derivative of this, which is 0.0306 t, then you evaluate this at 2, you will end up with 0.12 meter per second squared. Okay. I have Another this example is you have this cardboard, you have it is a square 12 by 12, then you cut it in each corner x by x, then you fold it, you get this box. So then the cardboard is the width and length is 12 minus 2x, because you cut x by 2x from each side. Then the height is x. So the volume is 12 minus 2x squared times x. That's area of base times height, which is length times width times height. So then to find the maximum volume and the minimum volume for that matter, you take the derivative. The derivative of this is 144 minus 96x plus 12x squared. So that's the first derivative. If you take the second derivative, it is minus 96 plus 24x. So if you set the first derivative equal to 0, then you will end up solving this equation. You will end up x equals 2 and x equals 6. Then one of them will maximize the volume, will give you maximum volume, and the other one will give you minimum volume. So the way to find which one is max, which one is min, is you evaluate this 2 and 6 to the second derivative. So that is v double prime of 2, it is negative, it gives you negative value. That means that is concave down. Concave down means you have maximum. So that 2 will maximize the volume. Then if you put the v double prime 6 in the second derivative, you will end up with the positive value. Positive value means concave up. Concave up means you have minimum. So the maximum volume is, you put this 2 into the volume equation, which is 2 times 2 is 4, 12 minus 4 is 8, 8 squared is 64, 64 times 2 is 128, that is the maximum volume. Then if you put 6 into the volume, 12 minus 2 times 6, which is 12 minus 12, which is 0, so that the volume is 0. That means you completely destroyed the cardboard. It's 6 by 6, that means no volume, which is 0 volume. Okay. So here I have area between the two curves example. So this is you have the top curve 2x plus 3, and I have a bottom curve which is x squared. So find the point of intersection by setting the top and the bottom equal to each other. So that will give you a equals minus 1, b equals 3, which are these points and this point. Then you integrate this top curve minus bottom curve from minus 1 to 3. So you will end up with 10.67. Then I have here an example of related rate, which is medical application. You have tumor, cancer, growth due to tumor. So if you have, if it is in a sphere shape, and this tumor is shrinking due to medication, shrinking. So if it is shrinking at the rate of 1 millimeter per month, the radius, at what rate is the volume shrinking basically? When the radius is 3 millimeter. So you take, so the volume of the sphere is 4 over 3 pi r cubed. Then when you take the derivative, dv by dt is 4 pi r squared dr by dt, which is dv by dt is 4 over 3 pi 3r squared dr by dt. So that is to find the dv by dt is simply substitute the r's and the dr. So we know the r is 3, dr by dt is minus 1, so that will give you dv by dt is minus 36 pi millimeter cubed per month. What that means is when the radius is shrinking by 1 millimeter per month due to medication, then the tumor itself, the volume is shrinking minus 36 pi millimeter cubed per month. That's a significant shrink, so eventually it will shrink and it will disappear. That's the idea. Okay, so this another example is related rate example again. So this is a boat is approaching is bullet to the dock by winch, and this winch is pulling this dog. The R is changing and the X is changing, but the Y is not changing, so the height of the dock is the same. So then this is the question here is while the radius of the winch is changing by 3 feet per minute, what is the change, how fast is the boat approaching the dock when X is 12 feet. Okay, so the first thing is in this triangle we know the X is 12, Y is 5, then we need to find the R. R is 13, which is R squared equals X squared plus Y squared. Then R squared is equal to X squared plus Y squared, but Y is 5. This is not changing, so we can just put the 5 here. Then when you take the derivative of this whole thing with respect to time, so this becomes 2r dr by dt, then 2x dx by dt, and the 5 squared disappears, is constant 0. Then you will end up with dx by dt equals r over x dr by dt. So dx by dt is, then we know r is 13, x is 12, and the dr by dt is given 3. Then dx by dt is 13 over 4. So that is what that means is when the winch is changing by 3 feet per minute, then the boat is approaching the dock at the speed of 13 over 4 feet per minute. Okay, so this is another physics application. Maximum height of a projectile. So this is the height of the projectile is given as minus x squared over 110 plus x plus 100. Then find where y is the height and the x is the horizontal distance. Then find the height of the maximum height of this projectile. So the maximum height is, you take the derivative, which is minus x over 55 plus 1. You set the derivative equal to 0, that will give you x equals 55, and that x equals 55 gives you the maximum height, which is h of 55 equals 127.5. That is the maximum height of the projectile. After that maximum height, it will drop.
Continuity is a continuous. Had to keep my pedal down. One of the rules. Take two limits, the same value. F of c exists a limit, and the value are equal. It's continuous. The graph is lifting like a loop. In a real value theorem, there has to be a number in between, and it's guaranteed the number has to exist in the group. When we take the derivative, we get the instantaneous slope. Limit definition where x approaches 0. F of x plus h minus f of x all over h. The method's way too hard, there's a shortcut power rule. Take the power, put it in front, then multiply. Minus 1 and the new exponent is produced. Take 2x cubed and now becomes 6x squared. Don't forget your functions and their derivatives. Turn that function into something new. Sin x cos x, same sine and cos. Then there's product rule, x, y, prime plus y, x prime. You see division, it's quotient rule. Low d high minus high d low. Put it all over low, low. Composite function, it's just in row. Take the exponent and put it in front. Minus 1, then derivate the rest. Derivative, don't forget the inside function too. Derivatives. Derivatives, they're the base of calculus.